Hi, welcome to the video solution for Edexcel Physics. This is Edexcel IAL Unit 1, October 2019. So let's start. Question number 1. Which row of the table gives the meaning of a stated unit prefixes? Regarding prefixes, there are some standard prefixes that I will recommend that you must memorize, or if you keep practicing that you must know that there are some standard prefixes. I'll just give you some of these like 10 to the power minus 2, 10 to the power minus 3, and then minus 6, minus 9, and minus 12. There are other, but for you these are sufficient. These are negative powers. So 10 to the power minus 2 is called centi, denoted by C. 10 to the power minus 3 is milli, minus 6 is micro, minus 9 is nano, and minus 12 is pico. These are negative power prefixes, and we have some positive power, but frequently used is starting from 10 to the power 3, 10 to the power 6, 10 to the power 9, 12. So 10 to the power 3 is called kilo, plus 6, this is called mega or million, capital M. Don't confuse with this small m and capital M. Capital M is a big power, a positive power. Million or mega. 10 to the power 9 is giga, capital G. 10 to the power 12 is tera, which is T. So if you remember all these prefixes, so these types of question will be quite easy for you to judge or to choose the answer. They say that the first column is micro and the second column is centi. So micro is 10 to the power minus 6 and centi 10 to the power minus 2. So your option is A. Which row of the table, question number 2. All quantities may be expressed in terms of SI base unit. Which of the following are the base unit for the moment of a force? Moment of the force is the turning effect, and formula for moment of the force is moment of the force equal to force multiplied by moment arm or pivot distance or perpendicular distance, simply F into D. D is just not a distance, this is pivot distance or moment arm. So SI unit of moment arm, moment of force is Newton meter. And if you need to find SI base unit, so you just replace this Newton with the base unit. So Newton is kg meter s minus 2. So this is Newton and this meter is there. Meter square. So kg meter square s minus 2. So your option is B. Question number 3. A student measured the diameter of a length of a wire in order to determine its cross-sectional area. The following measurements were taken at various positions along the wire and at various orientations around the wire. All measurements are in millimeter, 1.57, 1.36, 1.54 and so on. Which of the following expressions should the student use to determine the cross-sectional area of the wire in millimeter square? So cross-sectional area of a wire is pi r square, where r is the radius. But you have a data set for the radius, that means this r is the mean value. For the radius. And remember, this is not the radius, this is the diameter. So first you figure out mean diameter, and once you have diameter, then you divide it by 2, you can have a radius, which will be the mean radius. So we can figure out which one is the correct one. So if you see the data set, in this data set there is some anomalous result which is 1.36. So if you have anomalous result, you just discard this and you don't include in your calculation. So find out the mean of these four numbers. So sum of these four numbers divided by 4 will give you mean diameter, and the mean diameter divided by 2 will give you radius, and it will be, if you do your calculation, I'm leaving it for you. So R will be 0.78. That means the area of this area of cross section of the wire will be pi times of 0.78 squared. So option is C. Question number 4, the area under each of the following graph represent a physical quantity. For which graph is the area under the graph not equal to work done? So if you see, the first graph is force into displacement. Indeed, if you find the area under the graph, so it will be F into D, and F into D would be the work done. And the second one is F into extension. So force into extension, F into delta X. This is again a work done. In fact, this is energy stored. And if you see, this is power time graph, and that means area under the graph will be half of PT. If you wish, you can also include half here or half here, it doesn't matter, but the sense of the meaning is work done. So half of P into T, but you look only this P into T. So P into T, this is the work done, as power is equal to work done upon time, or energy upon time. So W is equal to P into T. So this is also a work done. So of course these three are work done, so option must be D. But let's see, this is a stress strain graph. If you find the area under stress strain graph, so this is not work done, this is work done per unit volume. This is called energy density. So this is not just a work done, this is work done per unit volume, or what we call energy density. So option is D. That means area under stress strain graph is not just a work done, this is work done per unit volume. Question number 5. The steps on an escalator moves with a speed of 0.5 in the given direction. So this is moving that. The vertical component of their velocity is 0.3 meter per second upwards for the same stairs. 0.3 meter per second is a vertical component. Which of the following is a horizontal component? Quite easy and simple question. We have a resultant velocity, we have one of the component, we need to find the third component, that horizontal component. If you see, you have a right angle triangle, so this is your hypotenuse, and one of these is your opposite and the adjacent, and you know that a square plus b square is equal to c square. So you can say that if a is horizontal component of the velocity, so a square is equal to a square is equal to c square minus b square, that is 0.5 minus 0.3 squared, and then if you wait, and then yes, root if you remove the square. So clearly a will be equal to 0.4, and this is a general idea. In any right angle triangle, if hypotenuse is 5 and one of the side is 3, then the other side must be 4. Or if you say, if in any right triangle one side is 5, the hypotenuse is 5 and the one side is 4, then the third side must be 3. This is the relation. This is called Pythagorean pair basically. So option is 0.4. Question number 6 and 7 refers to diagram below. A uniform solid cube is placed on a table. The diagram shows the forces acting on the table and on the cube. So there are various forces: RT, WC, RC, WT, RF. And what are these? So RC is the reaction force of the cube on the table. force of cube on the table, RF, force of floor on the table, RT, reaction force of table on the cube, this one, okay. WC, weight of the cube, WT, weight of the table. The dot at the start of every arrowed line indicate the point at which the force can be considered to act. Which of the following forces has been drawn in wrong position? Okay, so we need to find which force is drawn wrongly. If you see the diagram, clearly the WC, because WC is the weight of the cube, and the cube is a uniform solid cube, uniform. So uniform object, weight is the point where weight is the, weight is considered to act at the center of gravity, and this WC should be, at the middle of the cube somewhere here, so it is wrongly drawn. So option is C. Question number 7, a uniform solid cube. Same question, same forces. Which of the following statement is correct according to Newton's third law? Newton's third law. So now you need to see the forces. So remember, in Newton's third law is force of A on B equals force of B on A. So you need to look for similar statement for all types of forces if you are finding Newton's third law pair. So if you see which one is following this statement, clearly if you see RC, force of cube on the table, force of table on the cube. So these two are in fact Newton's third law pair. RC is equal to RT. So your option is again C. Question number 8, an electric pump lifts water from a well through a height of 10 meter at a rate of 4 kg per second. The water leaves the pump with a velocity of 5 meter per second as shown. So this is the pump, water is going up and leaving the pump at the same from the same height, leaving at the same time. Here the velocity is 5 meter per second. Which of the following expression could be used to determine the minimum power output of the pump in watts? So if you need to find the power, then you need to see how much energy of the water has at that moment. Clearly water is gaining height, so water has a gravitational potential energy. At the same time water is moving with the speed of 5, so water has kinetic energy at that same point. So at that moment the output power should be equal to the GPE. Due to height gain and due to motion, it must have a kinetic energy. So sum of these two energy per unit time will give you the output power. So power must be, is mgh plus ek half mv square, but this is the energy divided by time. Clearly if you split this t under these two terms, so you can write m by t gh plus half of m by t into v square. So m by t is a mass per unit time, which is 4, and h is the height. So you can write this is 4 and 9.81 or 9.8. H is the height is 10, so into 10 plus half of m by t again into 4 into v square, that means 5 square. So this is the power of the pump, and if you compare, option is C. Question number 9. A student used a falling sphere to determine the acceleration of free fall. A camera produced an image of the sphere at constant time interval as it fell. The position of the sphere in the first two images are shown. Image 1 shows the sphere's position at the instant it was released. That means at that moment initial velocity was 0, and all the pictures or the images will be taken at the constant time interval. And okay, so this is U, this is the thing. Question is, which of the positions P, Q, R, S will the sphere be at an image 3? So image 1 and 2 is given. We need to find the position of image 3 when the picture is taken. So if you see what is going on, that if you see we have equal interval, these dots are at equally spaced, and the time between these two images is t, and we need to find position of third image. That means the next time will be 2t. So if we assume that this distance is s, suppose, and this distance s, time taken is t, and if we use s is equal to ut plus half at squared, and u is 0, that means s is equal to half of at squared. This s is the distance when time t is taken by the sphere. So this s is for that these two images. We need to find what if time is double, because we need to find the third image. Third image means this third image will be at 2t when the time is double. So let's suppose the new position is s dash. So s dash would be equal to half of a, this t will be 2t whole squared. So half of a into 4, 2 square is 4, and t square. If you rearrange, s dash is equal to, if you rearrange, I'm not cancelling 2 and 4, I'm just rearranging. 4 I'm bringing before half, so 4 of half of a t squared. That means s dash is in fact 4 times of s. 4 times of s. So this is s, this is 2s, this is 3s, this is 4s. That means at r, at 2t, the sphere should be at r. So option is C. Question number 10. A force F was applied to compress a spring by a distance x. A second spring of double the stiffness was compressed by the same distance x. Which of the following gives the magnitude of the force applied to the second spring? So we need to find the amount of force for the same extension. So we know that Hooke's law suggests F is equal to kx. I am not including minus sign, it's just a direction. So F equal to kx. So for a given extension, because they say that the extension is same, so for a given extension, F is directly proportional to the stiffness. So if stiffness is double, force will be double. So double the stiffness, double the force. That means your option is B. Question number 11. A rope is used to pull a box a fixed distance s along a horizontal surface. The rope is at an angle of theta to the horizontal and a constant force F is applied to the rope as shown. So constant force, theta, direction of motion. Explain how work done on the box by F varies as theta varies. So you know that if force is making some angle with the direction of motion, then the work done is found by the formula W is equal to F of cos of theta into distance travel. So generally, if you say that the work done for a given distance or given force, work done is directly proportional to the cos of theta. And since if theta is decreased, if you decrease the value of theta, then the value of the cos theta will increase. And you can check by use your calculator, you can check theta is equal to 0 degree, sorry, not 0, because you need to decrease. You start with some angle, any angle, like let's suppose 60 degree, find cos theta, or cos 60, and then change 60 to 50 degree, and then find cos 50, and then 40 degree, so find cos 40. So you will visualize as theta is decreasing, so value of cos keep increasing. That means work done, that means work done is going to increase. So I'm giving you in a shorthand form. You need to write your statement about this behavior. So you say that if theta is decreased, then the cos theta is going to increase due to the fact due to which the horizontal component f cos theta, so due to this f cos theta is going to increase. The horizontal component of the force is going to increase, so amount of work will increase. Question number 12. A student set up the apparatus shown, inclined plane, distance d. When released from a height h, trolley A ran down the slope and then continued to move horizontally. On the horizontal part of the track, a frictional force F brought a trolley to rest over a short distance d. The trolley has a mass m. The student measured d for a range of height h. The student plotted the following graph of d against h. A straight line passing through a region. Okay. Derive an expression for the gradient of the graph in terms of F, M, and G. So remember, F is the resistive force. Okay. M is the mass. G is the acceleration due to gravity. Of course, when the trolley is coming down, so we have decrease in GPE. So we have change in gravitational potential energy. So at that point, the trolley would have kinetic energy, mean decrease in GPE will, of course, it will gain a kinetic energy. But at that point, it will have a maximum kinetic energy, and this kinetic energy does work against the frictional force. So indirectly, decrease in GPE is equal to the work done against the force. So first, let's just figure out the gradient of this graph in general. So gradient of this graph, G, gradient of this graph is rise over run, and rise will be the D and run will be the H. But we need to give gradient in terms of force, mass, and G. In terms of, so we need to replace D and H with these three variable. And what did I say? That the loss in gravitational potential energy, gain in kinetic energy, which will be used in order to do work against the frictional force. So I say that delta GPE is equal to work done against F. So mgh is equal to work done against force. So a frictional force F and distance traveled is d. So F into d. And you rearrange this equation in the form of d upon h. So send h here, and F down. So d by h is equal to mg by F, and this is your gradient. D by h is your gradient, so your gradient would be equal to mg by h. That's how gradient in terms of mg sorry, I wrote mistakenly h. It's not h because h we have replaced, so this is not h here, mg by f. I'm sorry about that. So final answer is gradient equal to mg upon f. In a second experiment, an identical trolley B was placed at rest at the bottom of the slope. When the trolley A was released, as before, it rolled down and collided with trolley B. After the collision, the two trolleys joined together and moved off to the right with a velocity v. A student predicted that the provided friction was ignored. V is equal to 2gh upon 2 square root. That means v is the final velocity after collision. It's all about momentum. In fact, because we have a collision. So assess whether a student was correct. Okay, so what is happening? As trolley A is falling down, the trolley A is gaining velocity. So when the trolley reaches at the bottom, just before the collision, the trolley has some velocity because it was moving. So we need to figure out the velocity of this trolley A. So you know that as it is falling from height h, that means GPE is converting into kinetic energy. So GPE is mgh is equal to half mv squared. So mass gets cancelled. So V is in fact 2gh root. This is general expression if some object is falling from height h and you need to find the velocity at the bottom. So suppose, because this is all about momentum, so we assume that the velocity of the trolley A is u at that point, just before the collision. So momentum of trolley A before the collision would be m into u, and m is the mass or u is the initial velocity before the collision. And as per this formula, at that moment, the velocity u would be equal to 2gh. So velocity u is 2gh root. And we don't have a momentum of the trolley B before collision, so equal to momentum after collision. And after collision, both the trolleys join together as per the statement, and they are moving together with the velocity v. Remember, please remember, don't confuse with this v, this v. This is the explanation that I gave you just for your understanding. Fine. So and then later on I say that the initial velocity is u before collision. Now what is happening after collision? Both the trolleys are moving together with the velocity v. So total momentum after collision would be m plus m, total mass into velocity v, and clearly you can say that m times of 2gh root 2m into v. M gets cancelled, so v is equal to 2gh square root divided by 2. And you see, if you compare what is going on, we need square root over the whole fraction. So what can we do is, we take this 2 inside the root. So if we take this 2 inside the root, so we will have to write 4 because we are taking back into the root. So we need to write 4. Now 2 and this 4 gets cancelled. So underneath we have a 2. So V is equal to finally GH upon 2 under root. So you must write your statement. Yes, he was, or a student was correct. Thank you very much. See you in the next video.